Hi, this lesson is about implicit differentiation. Implicit differentiation is a technique to take the derivative of implicitly defined functions. So to understand that, we need to understand the difference between explicit versus implicitly defined functions. So an explicit function is a function where the dependent variable is expressed in terms of the independent variable. This is what we're most accustomed to. Y is a function of x. With implicit, they could be functions, so we're going to call them implicit equations because they might not be functions. An implicit equation may or may not be a function. Usually the x and y variables are on the same side of the equation. All explicit equations can be expressed implicitly, but not all implicit equations can be expressed explicitly. In other words, it's not always possible to isolate the y variable from the x variable on one side of the equation. So this is an example of an explicitly defined function, and we're going to take the derivative of it both explicitly, and then we're going to rewrite it implicitly and take the derivative again, and we'll see we get the same answer. So when we take the derivative of y equals 3x minus 2, that means you're taking the derivative of y with respect to x. We're used to calling that dy dx or y prime, and we're taking the derivative of the right side also with respect to x. So the derivative of y with respect to x, as I said, is dy dx or y prime. The derivative of 3x is 3, and the derivative of minus 2 is 0. So my derivative is equal to 3. Now, if I take this equation and rewrite it implicitly, that means I want my x and my y's on the same side. So 3x minus y is equal to 2 is the same equation. So when I take the derivative on the left side and the right side with respect to x, the derivative of 3x with respect to x is 3, and the derivative of y with respect to x is dy dx or y prime. And the derivative of 2 with respect to x is 0. So if I solve this for dy dx, that means I subtract the 3 over to the right, and then multiply both sides by -1, and you get the same answer that we got above. Dy dx is equal to 3, so we get the same answer whether we take our derivative implicitly or explicitly. So let's do another example. We're going to take the derivative of y equal to 1 over x, both explicitly and implicitly. So explicitly, first thing we want to do is rewrite 1 over x as x to the -1 so that we could use our power rule. Then I'm taking the derivative on the left and on the right with respect to x. So dy dx is y prime, it's right here. And when I apply power rule, that's negative x to the -2. And then just rewriting that in a different way, I get that dy dx is equal to -1 over x squared. Okay, so now we will take the same derivative, but we're going to rewrite that equation implicitly, which means multiply both sides by x, so I get xy equals 1. So now my x's and my x and my y are on the same side. So I take the derivative of the left side and the right side with respect to x, but on the left side, I have x times y, so I have to use product rule. And that's what I did here on the next line. So this is x times the derivative of y, which is dy dx, and then the derivative of x, which is 1 times y, so that's 1 times y. And on the right side, the derivative of the constant is just 0. So now I have this equation for dy dx. So the first thing I did was subtract y over to the right, so it becomes -y, and then divide both sides by x to isolate dy dx. So I get dy dx equals -y over x. Now that doesn't exactly look like this original answer, but I can simplify this further because I know that the original equation is y equal to 1 over x. So I'm going to make that substitution right here. And so I have dy dx is equal to -1 over x divided by x. And when you simplify that right side, you get -1 over x squared, which is the same answer that we got when we did it explicitly. So same derivative value, whether you take the derivative implicitly or explicitly. Okay, so here's another one. It's similar to the previous one. This one is already defined implicitly. And on the left side, I do need to use product rule again. So here's my setup. I'm going to let f equal 5x squared, g equals y. F prime is 10x when you take the derivative with respect to x, and the derivative of y with respect to x is y prime or dy dx. So I'm going to use y prime notation in this problem. So when I put that together in the product rule, here we have, I did gf prime plus fg prime, and the right side, the derivative of -2 is 0, so the right side becomes 0. And then I need to isolate y prime. So first subtract 10x over to the right side, and then divide both sides by 5x squared, which is what you see here. And then if you simplify the right side, you get -2y over x. So it is fine to leave your answer in terms of x and y, but I showed you here that we could solve this for y and make a substitution. Y is equal to -2 over 5x squared. So if you plug that y value in to what your derivative is and simplify it, you get that y prime is equal to 4 over 5x cubed. So it's just two different ways of presenting your answer, either in terms of x and y or just in terms of x. Okay, but that can only be done when your equation can be expressed both implicitly and explicitly. Okay, so here we're going to do one where you can't solve this for y. So this is only defined implicitly. So I need to use chain rule in this case because I have sine of x as my outer function and x plus y is my inner function. Remember, we're taking the derivative with respect to x. So anytime you're taking the derivative of the y, you need to write that as y prime or dy dx. So using chain rule, this will be 3 cosine of x plus y. So this is the derivative of the outer function times the derivative of the inner function. And so that derivative is 1 plus y prime. And the derivative of 0 is still 0. Then I also divided both sides by 3 to cancel this coefficient here. So I'm left with cosine of x plus y, because now I also distributed this function across here. So I have cosine of x plus y plus y prime cosine of x plus y equals 0. So now again, just like the previous examples, I have to isolate y prime. So I subtracted this cosine of x plus y over to the right. And then I divided both sides by cosine of x plus y, leaving me with this expression, but the right side cancels to a constant of -1. Okay, so here's another problem that is defined implicitly. And we're going to find y double prime. So I have x to the fourth plus y to the fourth equals 16. So I don't have to use product rule like I did in the previous two examples. These are two separate terms. So the derivative of x to the fourth is, we're just using power rule, that's 4x cubed. And the derivative of y to the fourth is 4y cubed times the derivative of y, which is y prime. And the derivative of 16 is 0. Now the rest of this is just algebra. I need to isolate y prime on one side. So subtract the 4x cubed over to the right, like we did here, and then divide both sides by 4y cubed so that y prime is alone. And then just simplify the right side, and you get that y prime is equal to -x cubed over y cubed. Okay, but remember we were asked to find y double prime, so I need to now take the derivative of y prime, and in order to take the derivative of this, I have to apply quotient rule because I have a numerator and a denominator. So that's what I did here. This is the denominator times the derivative of the numerator, so that's g f prime, minus the numerator times the derivative of the denominator. But the derivative of the denominator, remember, we're taking the derivative with respect to x, so that denominator is 3y squared times y prime. In other words, follow y prime with your derivative of anything regarding y. So if it's y cubed, you get 3y squared y prime. But when it was just y, then the derivative would just be y prime. Okay, so we can do some simplifying. So this first term just becomes negative 3x squared y cubed. The second one becomes a positive because I have a double negative here. So that becomes plus 3x cubed y squared. But notice that I also substituted the y prime with what y prime is equal to, and I plug that right in here. So we don't want y prime in the answer of y double prime because we know what y prime is equal to. So you replace that with negative y cubed over y cubed, negative x cubed over y cubed. And my denominator, the g squared in the formula, that's y cubed squared becomes y to the 6th. Now the rest of this is just some simplifying. So this expression in particular, the y squared here cancels with 2 of the y's in the denominator and the x's combined. So this becomes a minus 3x to the 6th over y. And then what I did was I got a common denominator for the numerator. So these two will get a common denominator, which means the first one will get multiplied by y over y. So that top becomes what you see here, negative 3x squared y to the 4th minus 3x to the 6th over y. And divided by y to the 6th is the same as multiplying by the reciprocal of 1 over y to the 6th. Which then means that I can combine the y's in the denominator. So these y's, y times y to the 6th becomes y to the 7th. And if I factor out what these two have in common, that's negative 3x squared, which leaves me with negative 3x squared times y to the 4th plus x to the 4th. Okay, but interestingly enough, the original equation that we started with was equal to x to the 4th plus y to the 4th is 16, which is exactly what I have in here. So I replace the next line with what that's equal to, which is 16. And when I do that multiplication, your final answer for y double prime is negative 48x squared over y to the 7th. Okay, so that's a pretty interesting problem, the way that all worked out. Okay, here's another implicitly defined equation. I have 4 cosine of x sine of y equals 1. Once again, I need to use product rule because I have a product of two functions. And so my setup is here. F is 4 cosine x, f prime is negative 4 sine of x. G is sine of y, g prime is cosine of y, y prime. So when I put that together, this is f g prime plus g f prime, and the derivative of the right side is 0. Then your goal is to get y prime alone. So in the next line, all I did was I put the minus in front. So you get 4 cosine of x cosine of y, y prime, minus 4 sine of x sine of y equals 0. Then to isolate y prime, I added this one over to the right. Then divide both sides by 4 cosine of x sine of 4 cosine of x cosine of y, leaving you with this equation. But that could be further simplified because sine over cosine is equal to tangent. So my final answer is that y prime is equal to tangent of x times tangent of y. Okay, here's another that is implicitly defined, and we want to find the slope of the tangent line at pi 1 for e to the y cosine of x plus 1 plus sine of xy. So this one has quite a bit going on, because on the left side, I need to use product rule. On the right side, well, the 1 is easy, but this one here, it's chain rule, and within chain rule, I have a product, which is xy, so it's chain rule, and within chain rule, I need to use product rule. Okay, so let's deal with the left side first. So this is fg prime, so it's e to the y times the derivative of cosine, which is negative sine, plus f prime, which is e to the y times y prime, times g, which is cosine of x. Okay, so now we move on to the right side, and the derivative of 1 is 0, so that's what we have first. And then it's chain rule, so the derivative of sine is cosine of xy times the derivative of the inside, which is product rule. So that's x times y prime plus 1 times y. Okay, so now that's really the calculus part. The rest of this is just simplifying it and getting y prime on one side of this equation by itself. And I have y primes on both sides. So the left side didn't change too much. I just put the negative in front of the first expression. But on the right side, I distributed cosine of xy across those parentheses. So you're left with xy prime cosine of xy plus y cosine of xy. So now I can see that I need to get my y primes on the same side. So I subtracted this one over to the left, and I added this one over to the right on the next line, leaving me with y prime e to the y cosine of x minus xy prime cosine of xy equals y cosine of xy, and here's the one I added over, e to the y sine of x. Then factor out a y prime. Remember, that's what we need to isolate, so we need just one of them. So that leaves me with y prime times the expression inside the parentheses, and the right side didn't change at all. Now that expression in the parentheses gets divided so that my y prime is alone, and I'm left with this as my answer for y prime. But I'm not quite done, because remember, you were asked to find the slope of the tangent line. That is the derivative, but we need to plug in this point, and I have both x's and y's. So my x is pi, my y is 1. So that's exactly what I did right here. So that leaves me with 1 times the cosine of pi, which is equal to negative 1, plus e times the sine of pi, but the sine of pi is 0, so e times 0 is just 0 on the next line. And then the denominator is e times the cosine of pi, so that gives me negative e. And here I have pi times the cosine of pi. Cosine of pi is negative 1, so 2 negatives gives me a plus pi in the denominator. So when I simplify all of that, I end up with negative 1 over pi minus e. I just put the pi first since it was positive. Okay, so that was it for implicit differentiation. This is kind of a unique problem that I wanted you to see. So this problem says, let L be a tangent line to the hyperbola xy equals 7. This is also implicitly defined. That one could easily be, you could take the derivative either implicitly or explicitly. So L is a tangent line to xy equal to 7 at x equal to 6. So you can see that right here. The tangent line is in pink. My hyperbola is in this bluish green color. And we want to find the area of the triangle bounded by the line and the coordinate axes. That means the x and y axis. So the area that I'm trying to find is the area that is shaded here in pink. So that triangle. And we know that in order to find the area of a triangle, so this goes back to geometry, that's 1/2 base times height. So what I really need to know is, what is this and what is this? Because that would be my base and that would be my height. But in order for me to be able to identify that, I'm going to need to know what the equation of the line is. I can see it, but I don't know what the equation is. So that I can find the x and y-intercepts. The purple points here, this is the x-intercept. That would allow me to identify the base. And this one over here is the y-intercept. and that would allow me to identify the height. All right, but to find the equation of a line, I need a slope. I can see the point, but I need a slope. And to find the slope, it means I need to find y prime. So I did find the derivative implicitly, and on the left side, I need to apply product rule. And we did this one before, xy. So this is x times y prime plus 1 times y, and the derivative of 7 is 0. When I solve for y prime, I get negative y over x, so subtract the y and then divide by x. And then I can plug in my number. And this is the number right here. So my y is negative 7, y is 7, 6, so that becomes negative 7, 6, and x is 6. And when you simplify that, your y prime, or your slope, is negative 7 over 36. Okay, but that means that I can now find the equation of the line that I'm interested in by using the point-slope formula. So I get y minus 7, 6 equals negative 7 over 36 times x minus 6. And when I distribute negative 7 over 36 on the right side, you get what you see here. And then I have to add this over to the right to isolate my equation, isolate the y. So I get y is equal to negative 7 over 36x plus 14 over 6. But 14 over 6 simplifies, so that is the equation of the line. Okay, but now that I know the equation of the line, I can find my x and y-intercepts. My y-intercept is when x is equal to 0, so that's 0, 7/3. That's going to represent the height of the triangle. And my x-intercept is when your y is equal to 0, which is what I did here. And if you solve that for x, you get that x is equal to 12. And so my x-intercept is 12, 0, which means that the base is 12. So now that I know the height and the base of that triangle that I drew before, it's 1/2 base times height. That's 1/2 12 times 7/3. And when you simplify all of that, I did 12 times 7 is 84, and then I did the 2 and the 3, that's 6. And so 84 divided by 6 gives me an answer of 14. And so that is the area of the triangle that I drew and shaded before. And so just to remind you, that's the area of this triangle right here. This was the x-intercept that we found. This was the y-intercept that we found after we identified the equation of the line. So that's kind of a unique problem that I suggest you try to understand. Okay, so that's it for this lesson. Give the homework a try. Good luck.